Hello and welcome to Chapter 1 of AP Statistics. In Chapter 1, we're going to be discussing data. We're going to talk about different kinds of data, how to organize data, and most importantly, how to display data. So starting with our first video here, we are going to focus our attention on categorical data. Now, categorical data is, I would say, probably not as mathematically relevant compared to quantitative data, because quantitative data deals with more numbers. And categorical data, as we'll see here, by definition, it is a variable that places an individual into one of several groups or categories. So one way, easy way to remember categorical data is typically it doesn't deal with numbers. It's going to deal with words, for instance. So we might be talking about gender. We might be talking male, female, or whatever other types of genders you might identify as. We could talk about eye color being brown, blue, green, hazel, etc., etc., etc. Car models, and then I get into some numerical categorical data like area codes. Like I'm in the area code 618, rep. But you might be in a different area code. Zip codes is also a categorical variable. And the easy way to remember if a number is a categorical or quantitative variable is whether it makes sense to do math with it. Okay? So imagine you've got, let's say, my zip code and your zip code. Would it make any sense to find the average zip code between you and I? And it really wouldn't make sense to find an average zip code. Just like it wouldn't make any sense to find the average area code between multiple people. So just keep in mind that when you see numbers, it's not an automatic quantitative data variable, but you have to think about, does it make sense to do math with it? Now, one of the other things I have here is a Likert scale. And a Likert scale is something like, on a scale from 1 to 10, how would you most identify with your satisfaction with your most recent trip to Starbucks? But Likert scales also contain things like, on a scale from strongly disagree to neutral to agree to strongly agree, how would you rate your whatever? Okay, so in the next video, when I start talking about quantitative data, I'll come back and talk about Likert scales again, because it really depends on which scale you're going to use. If you're going to use more words like agree, strongly disagree, or if you're going to use numbers, because then you could talk about math using numbers like on a scale of 1 to 10, what was the average satisfaction rate? Now, we're going to talk about two different ways of tallying or organizing really our data here and showing our data. And we're either going to call it by frequency, which is just counts or the actual numbers that, like if you had 12 people that had blue eye color and 24 people that had brown eye color, that would be by frequency or by count. But we could also convert those counts into percents, and we're going to call the percentages relative frequencies. So we'll do some examples where we'll show some frequency categorical variables, and we'll also discuss how to convert them to relative frequencies, which really shouldn't be that terrible. So first, here's a set of data. Here's a set of categorical data. So international students in the United States. And I've got a list of, about 10 states here, and then other states in general. And you can see this is our categorical variable, is state. Now, granted, we do have, maybe 40 states in this last group here, but still, these are by states, and we're just going to call this last group the other states. So here's by number, here's by frequency, and we can see in total there are 975,000 international students in the United States. But we can also look at those numbers by percents or by relative frequency. Now, one thing you might notice in particular that seems kind of off here is, how come the percent is 100.2? Shouldn't it be exactly 100.0%? And that would be a good thing to question. Now, the main reason why this is 100.2% instead of just 100% flat is all of these percentages have been rounded, if you notice, to the nearest tenth. And because of those roundings, it causes some slight fluctuation. Some parts get rounded up, some parts get rounded down, and in the end, we kind of had more rounding ups than we had rounding downs, which caused us to have this extra 0.2% higher than what we should have. So don't think because you see 100.2% that you're off. It's probably just because of the individual numbers that added up to that 100.2% that all those numbers were rounded, and it's just due to rounding error. So if we wanted to graph now one categorical variable, you might use, for instance, a pie chart. And I know pie charts aren't new to you guys. These are relatively old things that you've seen many, many times in maybe different textbooks or in newspapers, if you guys even know what newspapers are anymore, or on websites. You guys know what websites are. So here's my question. Why do you check your email? And there were 3 different responses. So my categorical variable is the type of response here. And I had about 8% people say to communicate, 2% said out of boredom, and the other 90% was to confirm their email address at a new website. So pie charts, pretty common things. Typically you show them in percentages. You don't have to put necessarily the percents in the pie chart. You could put them over here next to your key, but it is important to have some sort of key. And if it's not color-coded like this one is, then you probably want to use some sort of lines or striations, like maybe you've got a striped box, and then you would know for sure, like, oh, well, this one matches up to that one. And maybe one has polka dots in it, and so if you find that one that has polka dots in your pie chart, you would know that matches, if, again, it wasn't color-coded. Another common thing that I'm sure you guys have seen are called bar graphs. Now, this is the top 10 mobile apps by penetration of app audience. And here's the source that I got that from. And you'll notice this is in relative frequencies, right? Because this is based on percentages and not actual counts. So we don't really know, unless we go and look at the source for more information, how many people really responded to this survey, if you will. All we know is that 81% of people that were asked have Facebook as an app. Likewise, all the way down to 41% of all of our people, and again, we don't know how many people that is, have Pandora as an app. Now, one thing you might notice is, notice that all these bars are in decreasing order. Do they have to be in decreasing order? No, they could have all been in increasing order, for instance. And we could mix all of these up if we really, really wanted to. Facebook could be right in the middle of all these, and it looks kind of weird that you would have a decreasing and then a sharp increase and then decreasing again. But this is a categorical variable. In bar graphs, it really doesn't matter where each bar is. The one thing to note here is notice that between the bars, there are gaps. And that'll be really, really important, because when we get to quantitative variables, we're going to discuss a histogram. And a histogram looks a lot like a bar graph, but there are no gaps in it. So just note, and again, bar graphs, they don't have to be in any particular order. I could easily take the Facebook bar, put it anywhere I wanted to, and these could just be all scattered about in here. They don't have to be from decreasing or increasing order, however you want to show them. Now we're going to get to 2 categorical variables. So here's the 2016 Summer Olympics medal table, and I just took the top 3 countries here: the United States, Great Britain, and China. And here's gold, silver, and bronze. So our 2 categorical variables are medal type, and it's broken down into 3 categories: gold, silver, bronze. And our other categorical variable is country, which we have 3 possibilities of: the United States, Great Britain, and China. Now, if you notice, here are all those values taken. And a new concept here is called the marginal distribution. And there's 2 different ways of looking at marginal distribution with 2 categorical variables. It depends on which variable that we're referring to. So I'm going to go ahead and start with the one that I already have the numbers for here. And you can think of the marginal distribution as kind of like the subtotals, if you will. Okay, so if we look at how many medals did the United States have in the 2016 Summer Olympics? Well, the United States altogether, gold, silver, and bronze, had a grand total of 121 medals. Great Britain had 67 overall medals. China had 70 overall medals. Now, if we wanted to just talk about these values here, if we wanted to focus just on the United States, separately from Great Britain, separate from China, we would call that the marginal distribution by country, if we're going to break it down and split up the three countries. Now, we could also talk about the marginal distribution by metals. So regardless of where the gold medals were from, let's focus on how many gold medals there were altogether. So we could come up with all of these subtotal numbers. How many total gold, silver, and bronzes were there? Well, if I took 46, 27, and 26, that'd give me 99 total gold medals by the top three countries. There were 78 silver medals altogether and 81 bronze medals altogether. And then usually down here in the bottom right corner is really the total of all together how many medals are we talking about. So by all three countries and across all three types of metals, there were 258 total medals won by these three countries. So again, marginal distribution is whenever you really focus on one variable at a time. And since we're talking now about two categorical variables, there's two different types of marginal distributions to discuss. And we'll get more in depth in these later on. If you wanted to focus on just one of these marginal things, then we're going to call that a conditional distribution. And we're really going to talk about this when we get to our probability chapter in chapter 5. So we might say, for instance, given that we're going to talk about gold medals only, then what's the probability that the United States won a gold medal? And then you would say, oh, well, if I'm only looking at gold medals, well, the United States won 46. Out of how many gold medals altogether? 99, if we're, again, only talking about the top three countries here. So if you wanted to talk about one specific piece of and this is a two-way table here, but of a two categorical variable set, then we would call that the conditional distribution, just one piece. And we could do conditional distributions of a country. We could say, given that we only want to focus on the United States, then we would say, all right, then we're only going to look at all of these numbers here because all of these numbers belong to the United States. And then what would we do with Great Britain and China's numbers? We would simply just ignore all of these other values because they don't belong to the United States. So marginal distributions is when you want to talk about one categorical variable across the board. And then a conditional distribution is when you just want to focus on maybe one or not all of the marginal distribution. So how do we graph this information? Because it's kind of hard to make a pie chart or a bar graph when there's multiple bar graphs or pie charts to be made here. So here's an example. We can use a bar graph, but we have to use a specialized bar graph. And it's called just simply a side-by-side bar graph. So here's a side-by-side bar graph by country using frequencies. Remember, frequencies was just a fancy word for by count. So if I looked at the United States, and if I have this by country, then here's all the United States's, here's all Great Britain's, here's all China's medals. And notice I color-coded this because I could. But again, if you didn't have these color-coded, you could simply do like what I have here and have G, S, and B for gold, silver, bronze. Or you could use some sort of like striped lines or dots or whatever, just so that I would know which one was really gold and which one was silver and which one was bronze. Because I never want you guys to assume that it always goes gold, silver, bronze. Because some people might say, well, I think it goes bronze, silver, gold. So you have to have typically some sort of key or make it well known which bars are which. And notice how I have all this stuff labeled. You know, I have each country labeled down here. I've got the gold, silver, bronze labeled. I've got my vertical axis labeled appropriately and spaced appropriately. And more importantly, I have, what do these numbers represent? These represent actual counts or frequencies, if you will. Now, if we wanted to look at a side-by-side bar graph by metal, but still by frequency, then we could say, hey, instead of this being the US, Great Britain, and China down here, then let's do gold, silver, bronze. And then let's look at all the gold medals by these top three countries. Let's look at the silver medals by all three countries. And let's look at the bronze medals by all three countries. Now, if we wanted to convert all those frequencies or counts into percentages, this should be a really easy thing for you guys. So for instance, if I wanted to focus just on metals. So then what I might do here is say, well, the United States had 46 gold medals out of 99 medals altogether. So 46 divided by 99 gives me 0.46 repeating, really. And so I'm going to round this to the nearest tenth and just call this 46.5%. And then I could do the same thing for Great Britain's gold medal count. They had 27 medals out of 99, and that's 0.27 repeating. So if I round that to 27.3%, and then I can do the same thing for China and get 26.3%. And if I add all those up, if you notice, 5, 3, and 3 is going to give me 1.1%. This is really going to be 100.1%, but I'm just going to go ahead and call it 100% because that's what it really should be. And then if I break down the silver medals by country, well, the United States had 47.4% of silver medals. Great Britain had 29.5%, and China had 23.1%. And again, I should get 100% of all silver medals are tallied here, just out of the top 3 countries. And then for bronze, here's all the bronze values. So now I could take those percentages and redo my graph. And I could say, here's my medal count by percent, or you could even write by relative frequency, so that I would know that all these numbers really aren't counts anymore, but they're now percentages. So you can see I've got the same graph that I had earlier right here. These were by counts, but now I've converted them all into percentages. And we still see the same patterns there, right? The United States won in all of them, gold, silver, bronze. We kind of saw this decreasing pattern, and then this fluctuating pattern in the bronze medals. But one thing you might notice here is there's a whole lot of space between the 50 and 100% where there's nothing up here. So it seems kind of weird. Why would we have all this kind of empty space? Is there a way that we could fix this to get rid of a lot of this empty space? And what we could do is just restructure our vertical axis here. And instead of going by 20%, what if I counted by 10%? And since no country got more than 50% of a particular medal, then let's just say I cap this thing at 50%. Because again, there's nothing above 50. So all this does is really just stretches out your bars and makes it kind of easier to see. Okay? But notice in both cases, I do start at 0%, which is really important. Because a lot of times graphs will try to deceive you by not starting their vertical axis at 0%. All right, here's another way. Instead of a side-by-side bar graph, we could do something that's called a segmented bar graph. So here's a segmented bar graph by metal, right? Gold, silver, bronze. And then really taking those side-by-side bars, it's just stacking them all up. And again, this is by frequency. So I've switched this back from relative frequency to frequency. So these aren't percentages, because you might go, well, hey, look at all the silver medals. They're not at 100%. That's weird. Where's the other 20%? Well, we're not talking about percentages. We're talking about actual number, right? There were a total of 78 silver medals. So this is where this is going at. It's just right below 80%. Now, does it matter which country is on the bottom, which country is in the middle, which country is on top? Absolutely not. It's really up to you how you want to organize those. Could you mix up the countries from one bar to the next bar? Sure, if you really wanted to, but it kind of screws around with your mind if you start doing that. So I would try to be consistent. So I just put China on the top, Great Britain on the bottom, Great Britain in the middle, and US all on the bottom. All right, so here is another, this is going back to our side-by-side bar graph. We had frequencies. And so if I now wanted to convert from a frequency to a relative frequency and show that to you with our segmented bar graph, let me go back here. So again, I'm doing this by country now instead of by metal. So earlier we were going by metal, right? We looked at 100% of all the gold medals, 100% of all the silver, and we took like 46 divided by 99 and 27 divided by 99 and 26 divided by 99. But now if I went back by country, so now I want to look at this different marginal distribution. Now I'm going to be doing math more along these rows instead of by these columns. All right. So if I notice with the United States, They have 46 gold, 37 silver, 38 bronze. And altogether they had 121 metals. So if I start converting all those to percentages, so 46 out of 121 is about 38%. 37 out of 121 silver, that's about 30.6%. And 38 bronze metals out of 121 is about 31.4. And I just stack these in a gold on top, silver in the middle, bronze on bottom. So here's now, notice these are now by relative frequencies. I guess I should put that in a different color. These are by relative frequency. So now my vertical axis is back into percents. And what you'll notice here is that this does need to top out at 100%. Because if this doesn't go to 100%, I'm missing some metal somewhere for the US. So what I want you guys to do to finish out this video is I want you guys to do Great Britain and China's segmented bar graph. Okay, so again, I've got the data down here. You can see Great Britain altogether had 67 metals. So what percent is 27 out of 67? What percent is 23 out of 67? And what percent is 17 out of 67? And then do that accordingly. And to make it nice, I would like you to go in a gold, silver, bronze from top to bottom, just so that it kind of matches how I've already set up the US. Okay? And honestly, you're just going to kind of have to all eyeball and estimate where those percentages go exactly. All right? So I'm going to leave that up to you guys, and I will check that the next day in class. So good luck on that, and we will see you in video 2.